Good morning, everyone. Welcome to our talk today on writing highly genericized code with the dynamic Apex and the tooling API. My name is Javen Aurora, and I'm joined here today with Adam Olshansky, and we're both Salesforce MVPs, and we're excited to talk to you about this today. A little bit about me. I'm from Sline Consulting, where I'm the practice lead, and I'm part of an amazingly talented team that specializes in Salesforce implementations, custom development, and business process analysis. We're always looking to grow our team, so if you're interested, please come and find me. So, before I begin, just a quick word on the forward-looking statement. Don't make any purchasing decisions based on any forward-looking statements, and make them based on things that are currently available. Okay, so we have a really meaty talk today, so we're only going to touch on a few of these topics. But the overall goal that we have for you is we want you to think about the way that you structure your code, how you refactor it, and how you design solutions. So we're going to talk a little bit about generic code for Apex, what it means, what problem it solves for, how to do it. We're going to talk about applying design patterns in Apex and highlighting one of them. We're going to talk a little bit about dynamic Apex and how that lets us genericize methods to be able to, excuse me, to be able to write methods that can handle any type of S object. And then we're going to wrap up with a tooling API that lets us generate code at runtime. Cool. So, generic programming in Apex. What's the scoop? So we're trying to solve for lots of problems in generic programming, but it can be abstracted down to one thing. Who here has read code that looks like this? All right. I got another question. Who here has written code that looks like this? We have a couple of honest people in the house today. All right, so let's get real. What are we actually trying to talk about today? We're trying to write code that is not rigid. So something that it's very difficult to make the slightest of update to the code. Something that's tightly coupled. We're trying to avoid that. We want to avoid writing code that's super fragile, where we make a change in one place and it causes some unexpected changes elsewhere. That's really bad. Like this door, we can't reuse it anywhere else. Well, I sure as heck hope not. We want to avoid writing code that looks like that. And we want to avoid quick fixes and patches. Additionally, we want to avoid overly complicated data structures. Who here has come across maps of maps data structures? What about some 5-dimensional arrays? How do you even think about a 5-dimensional array? All right, well, so that's the point. We're trying to eliminate scenarios that are hard for a normal person to conceptualize. We're trying to eliminate scenarios that are hard for even a developer or an architect to conceptualize. Because if they're hard to conceptualize, they're going to be hard to maintain, hard to debug, hard to just, well, deal with. So what are the solutions? So when I'm thinking about writing better code, it can be handled in one of two ways. One is at the process level. So we can do stuff involving our entire team. We can have good code reviews. We can have a good definition of doneness, right? We can have good testing. We can allow time to actually refactor code when we're adding new additions and new features to it. That's all great stuff. But as a developer, what can you do? Well, you can address it with a code structure. One approach is with generic programming. So I'm throwing around this term maybe a little bit loosely, but here's what Adam Naar's take on it is. The idea is where you take similar implementations of the same logic and you condense them and you abstract them into one generic implementation that covers the entire problem space. That's what I mean about generic programming and generic programming algorithms. So how do you use that genericized implementations? Well, you kind of use it like a piece of plumbing. You know, you'll add other piping to it to handle your data, handle your process a little bit different for each individual use case, but the guts of it will be the same from all the different implementations. So what's an example? Let's take a case of a bidirectional data sync. Suppose you have an object in Salesforce called account with a field called segment, right? And then another database with a table called corporation and a field called sector. Okay? We have a bidirectional data sync between the two different tables and the two different databases where we're transforming the data in almost a similar way. It's basically a reflection of it. Now there's two ways to handle a problem like this. We can write, for each different side of the reflection, we can handle a different code base to handle it from corporation to account and account to corporation, which we can do, but we end up with a lot of duplicate code, a lot of stuff that just looks like it can be condensed. Or we can do something that handles a source destination problem with one helper class. That's kind of what the solution that we're going for with generic programming. Okay, so how do you do it? It's not easy, and it takes time, understanding, and just experience. It requires a good understanding of the problem space and the solution space. I'm beginning to find, as I progress in my career, consultants by nature are better at this because they see more problems than the end users. That's just what I've noticed. I don't know if anyone else has as well. But by seeing more problems, seeing more implementations of the same problem, you can abstract them away and have a better understanding of the problem space. What problems are we actually trying to solve for? You can abstract that away, get the core requirements of that problem, and then develop a scalable solution for not only that problem, but the space. So that's kind of where design patterns help us a little bit. They provide us a structured approach to solving the problem. So that way it's repeatable, reusable, and overall good, and you don't end up with that bathroom door scenario. Sorry. The other part of it is we identify the minimal requirements to the solution space. As we talk about design patterns, they're not like Legos that you can plug and play all over the place. If you do, you're going to end up with a headache of a code implementation that's overly complex and overly structured. You're going to want to use them as a template and take the parts of it that you need. Okay, so that's generic programming. How do you implement it? Well, it is a process. The way that I favor it is I start with design patterns. Does this problem that I'm looking at correlate well to the design pattern? If it does, awesome. If not, I don't try and force it. I call a friend and say, hey, let me take you out for a beer because I need to talk this out. And then see if they, with their expertise, they say, yes, it is a design pattern, or you know what, it's a different design pattern that I wasn't even thinking about. So there's a discussion if it's ever in conflict is really the main takeaway. Ideally, once you've identified the design pattern that you want to implement, maybe you're doing something involving generics and reflection. However, unfortunately, Apex only has partial support for generics and reflection. Maybe in 2099 they will, but until then, this is the world that we live in. So what do I mean by partial support? Partial support means that we have S objects, which give us a partial implementation of generics that allow methods to take in different types of S objects, so accounts, opportunities. One method can handle all that and return an S object. You just do some casting to help you. And you have describes, which give us a partial implementation of reflection, allows us to go and interrogate the field or the S object and say, hey, tell me some properties about you. In the non-S object world, well, we end up with, for lack of better words, Frankencode. Sometimes you just have to write it because that's the limitation of the platform. And you deal with that with the tooling API and custom types, which Adam will talk about. So, what are the benefits of generic code? At its core, it gives you a stable way to reason about how the code functions. It's predictable, it's easy to maintain, it's easy to add to, and best of all, it's easy to train new people and onboard new members to your team. And then, of course, the obvious stuff, so less duplicate code, which is nice, more portable, reusable, extensible, and it's easier to read. The easier to read one is kind of double-edged sword. In order to read design patterns a little bit easier, you have to understand them. And if you don't understand them, they're hard to read. So, you know, it's one of those things that get better with experience. Overall, design patterns or not, generic programming allows you to have a better understanding of not only the problem space, but the solution space. That's important because then your code and your solutions will be more robust. So, today, what we're going to do is we're going to walk you through a problem that a developer at another consulting company came up with and that we saw and we were just stunned by. And we came and got some new requirements for them and said, well, hey, how do we treat the code so it's scalable? And how do we apply some generic way of thinking to it? So, imagine, if you will, this scenario. It's pretty easy, but let's kind of walk through it a little bit slowly. Suppose your company has leads coming in from all over the world. Afghanistan, Belgium, Canada, Denmark, Europe, England, France, wherever. So they have leads coming in from all over the world, and leads from different countries are routed to specific teams when they're inserted. So all the teams from Afghanistan go to Team Alpha, all the leads from Team Bermuda go to Team Beta, and so on and so forth. Then, once it's assigned to each team has its own process for assigning leads. So Team Alpha follows maybe a round robin algorithm. Team Beta has maybe a random algorithm, what have you. The point is, each different team has its own different implementation for routing the leads within its team, and that's decided at runtime. So, how was this implemented? So each lead record has a country field. It's easy enough. And we have a custom setting that maps a country to a public group. So that way we get the binding between the public group and the country. Then of course we have a public group which has users as group members. Don't worry about nesting of groups today. That's just an unnecessary detail. So here's what we have in our declarative setup. We have Team Astro here with RD and test user. And then we have a custom setting with the different countries mapping to the different teams. Okay, so how did the developer implement his solution to handle the lead routing? Can you in the back read that? All right, I'll switch out. Give me one sec. How about now? More? Good? Okay. I'm sorry about that. Okay. So when our leads get inserted, what do? This is just the way that it was implemented, and it's kind of showing some problems in design structure, which is obviously why we're showing it. So we have different collections for each different team that they created. And then they get the mapping of the known countries to the public groups. Okay, it's not terrible, but not great. They loop through the different leads and sort them to their respective lists. So if there's an unmapped user, we send it to lazy load user. Okay, and then once we put them in the respective lists, we run through the specific assignment process for each team. So Team Astro, all their leads get followed by the Astro mapping and assignment algorithm. Sorry, the Astro assignment algorithm. Okay? Easy enough to kind of follow. So, what are some problems with this? Well, we have a lot of if-else statements, which are kind of ugly and kind of boilerplate, right? We have lists of collections, which, you know, just they can go on and on forever if we have if we add more public groups to it. And it's really tightly coupled. Not bad for a first attempt, right? But we're going to get some new requirements. But before we do, let's take a look at sorry about that. Can you read that in the back? Okay, good. Let's take a look at their lead routing algorithm for Team Astro. So here we see it's just assigned randomly. If the group has members, we assign it randomly to the people on the team. Otherwise, we send it, if the group has no members, we just send it to a default user. Okay, so now this new requirement comes in. Customer comes back to us and says, hey, the lead routing has been so effective, we love it, but now we want to add more and more public groups to it. And you know what, instead of just leads, we want to handle cases as well. So what are our options? We can have more collections listed in a method like that. We can have more if-else statements listed in a collection like that, but that's very tightly coupled, and it can lead to problems down the road. Also, what do we do about handling both leads and cases? We can have lots of duplicate code hanging around, but that's harder to maintain and easier to forget about, and whoever wants to write the test code. So what do? We use design patterns. So, what are design patterns? Let's back away for a second and think about them. They provide a structured template for thinking about the problem and solution. So some of you here probably already know where I'm going. For those of you who don't, let's act like you have no idea what I'm talking about, of where I'm going in this solution. What we have here is a problem where we have a list of algorithms that the user needs to implement, and they need to decide that at runtime. Well, that fits really well into design pattern that we'll see in a minute. So we've abstracted away the problem down to a really tightly understood design pattern. Now, what I've just been able to do is have a higher level of abstraction of the problem, which makes it more reusable. So now I've reduced it down from leads and routing and all that to a better simplified statement. I can use it elsewhere, and I can apply it to a larger set of cases. Because of that, it makes the architecture easier to understand and more accessible to others. So if I'm troubleshooting this, I can talk to friends about it and discuss it with them. And I can also train more other team members easily on it. And obviously, design patterns are well documented. So what are some common design patterns in Apex? There's about 10 of them or so. Here's a partial list. Design patterns are kind of being come up with every day, and if you do some research, you can find more. These are the ones that I use pretty often. Today I'm going to highlight one of them, which is called strategy. So what is strategy? Strategy is a pattern that allows you to encapsulate a collection of algorithms and choose one at runtime. Okay, that's a really fancy way of saying it allows you to put your different lead assignment processes into its own decoupled implementation, and allows the user to say, based on their input, which one am I going to run, which one am I going to choose? When do you use them? So a good use case is when you have a lot of if-else statements. So what we saw in that example, we only had three public groups, right? Astro, Thunder, and Lightning. But if we're going to onboard more and more public groups, that's a lot of if-else statements, which can be confusing and hard to read and, well, not so great. So that's a good use case for using strategies. Another use case is when you have a lot of similar business processes that you want to implement. So we have a list of behaviors here, which are different lead assignment algorithms, and we want to use them across the board. Right now there's 3, but we're adding more public groups, and it's easy to understand that, well, each group will have its own process. And finally, when we want to avoid exposing complex logic to the client process. What we had in our first version of the code that we saw was a tightly wound, tightly coupled method. We want to avoid that. Okay. So let's take a look at the code. Okay, so here's our strategy implementation. We're changing, so what we did was we took the existing code. We said, all right, we're going to spend an hour or two. We're going to rewrite how we think about it. We're going to change how we think about it, reduce it to a design pattern, and refactor it. So that way, going forward, we can handle more use cases a lot easier. So what did we do here? Well, we got our configuration up top, where we get the map of countries to the different public groups. That's the same where we're going into our custom setting and grabbing all the information. We then sort our leads into a map where we index them by group name. So before, how we had all of our collections and lists that we were dealing with, we were hard coding Team Astro, Team Benioff, Team Lightning, Team whatever. We've put those indexed to a map now. We iterate over the public groups key value pairs, and then for our values, we implement a custom router implementation and route the leads to that logic. So we're just doing some polymorphism here, which allows us to say, based on this group, send it to this object, and we're going to cast it as a base class router. Okay, not so bad. Let's take a look at the router class. So now we have our our base class, where here we have a virtual method and 2 implemented methods. Typically in strategies, you have an interface with classes that implement it, but here that didn't fit our problem. So again, what I wanted to highlight is we're using our design pattern as a template, which we're not following as gospel and as Legos, but we're using it more flexibly. So here we have a default routing algorithm that we override when we need to. And then let's look at our implementation. So this was the same method, more or less, that we saw earlier. We assign, for Team Astro, we assign the leads randomly, and then if the group is empty, we just assign to some default case. One difference here is on line 4 and 5. Because we're dealing with polymorphism and we're passing in the base class, we need to cast the records from an S object down to lists. So what have we just kind of looked at here? We've changed our approach to how we look at the problem. We've added a lot of overhead, but we've now made it so we can handle different public groups that we've added to the process. So that way, as we add more countries and onboard more groups, we can handle how we treat them. The code is decoupled from the client that calls it, and it's much more stable. We haven't dealt with the whole thing around cases versus leads yet, but I'll get there in a second. So, can I use design patterns like Legos to solve problems? Please don't. They're not Legos, and if you use them like Legos, slapping them in all over the place, just like plumbing, you're going to end up with a very leaky solution. It's going to have it's going to be overly structured. It's not going to make sense, and it's going to be a headache to not only maintain, but be a headache to add to. So they're definitely not Legos, and don't use them like that. What's the approach for using design patterns? So this is something that I struggled to articulate because it's there's not much of an approach to it. The approach that I use is I really try and understand the problem and reduce it down to its most base case that I'm trying to solve. Once I kind of identify the base case, I try and find a design pattern that it fits into. If it does, great. Part of my problem is solved. If not, you can't really force it. If you do force it, you end up with overly structured code that doesn't necessarily fit the solution that you need. Some trade-offs here is that it has a higher learning curve. So not only do you need to know how to program, but now you need to think about your design as well. So not only is it harder to think about initially, but it's also harder to communicate initially to your team. But that's fine. You're bringing people up. And it also involves more classes and objects. Okay. So we solved the first part of our problem statement. What about the part of the problem where we need our method to route leads as well as cases? That's where dynamic apex comes in. So there are lots of tools to the trade, and you could easily fill 3 or 4 hours talking about dynamic apex and dynamic sockle. At its heart, it allows you to describe metadata and describe the current state of the system to have a flexible implementation. So some of the tools are field sets and custom settings. Field sets allow you to have dynamic visual force pages, dynamic mappings, dynamic sockle queries. Custom settings allow you to implement different implementations of how your code should work. So if you imagine we have in our custom setting, we have each country mapped to a public group. Based on just updating custom setting from one group to another, we can change how the countries are mapped to the different public groups, and therefore the algorithms that they implement. Dynamic sockle allows us to generate queries at runtime. So if we have a query, if we don't know if we're dealing with a lead or a case, we can determine that at runtime and write a query that captures that exact query that we're trying to execute. Limits class is another good one. So that allows you to interrogate the current state of your execution context to say, how am I doing in the governor limits? Am I getting too close to this number of DML statements? If so, maybe before I execute the next part, I want to execute it asynchronously instead of synchronously. Stuff like that allows you with it helps you with routing. Schema classes allow you to describe the different metadata. So it gives you some information about your S objects, your fields, stuff along those lines. And the S object class is super useful because, well, that allows us to cast opportunities and accounts into S objects. Literally, we can go on for hours, but what we want to do today is just bring it back to the context of our example. So can you see that in the back okay? Okay. So this is a generic implementation of the method that we just did. A couple things to note here. Let's start with line 4. Instead of taking in S objects and then casting them in the last class, we're just taking in S objects here. Okay. And then on line 10, 14, and 18, how are we dealing with the records? So we're iterating over S objects, fine. And then we're using the record as a map, and we're putting the field and the field value there instead of doing a hard-coded field and the value. That's really the only change that's happening here. But now writing the method like this allows us to extend our method to handle more use cases. So let's take a look at actually a comparison between the two methods a little bit better. Can you see that in the back? How about now? Okay. So the diff tool picked up a little bit more than I hoped for, but really the main changes are on line 10, 14, and 18. That's really the only changes. It's how you're accessing the record and how you're to update it. That's really it. Okay. So we've talked a little bit about dynamic Apex. We've talked a little bit about the power behind it. I could literally go on, but I think what my goal was to kind of demonstrate a structured way to think about problems and then a structured way to design your methods to be able to handle any type of S object. Now Adam's going to bring us home. He's going to talk a little bit about the tooling API. Adam?
All right, thank you, Javen. All right, so my name is Adam Olshansky. I'm a Salesforce developer contracted through eTouch Systems at YouTube, also a Salesforce MVP. And wrong way. All right, so I'm going to talk a little bit about the tooling API today. How many people out there have heard of the tooling API? All right, most people. How many people have ever used the tooling API? All right, decent amount. So essentially, some of you may already know this, but it's named the tooling API for a reason, because at the end of the day, it's an API for building tools. There are a lot of things that we can do with it. Here are a couple of them. But at its core, basically what you can use it to do is to gather finely grained metadata about your org. You can look into classes, triggers, construct symbol tables, which I'll show you in a few minutes, look at code coverage queries, generate Apex on top of Apex, stuff like that. Also look into some of your business processes for an org, flows, custom items, workflow components, etc. You can also utilize it for source control and continuous integration, creating metadata containers, looking up deployment details, executing mock deployments, stuff like that. You can query it via REST or SOAP, or as I'll show you in a second, you can build a wrapper class on top of it in a language of your choice. It's also pretty similar to the metadata API, but kind of taking it one step further. Salesforce's idea was the metadata API is great, but we want to extend it to dive even deeper and be able to do some more things with it as well. All right, so I'm going to walk you through a scenario real quick here. And essentially what we're going to do is we're going to use that dynamic Apex Javen just talked to us about, and we're going to use it to write Apex using Apex. So an Apexception, if you will. All right, so I am going to walk into an org really quick here. Whoops. Maybe that's not what I wanted to do. OK. How do I get the broadcast back? 1 second.
I don't know. What do you do?
I don't know. I pressed escape.
OK, try this.
Yeah. There we go. OK. All right, so forgive me for showing you some code in the developer console real quick. But what we're going to do is I'm going to walk you through real quick how to execute some dynamic Apex here. And let's go look at a class called df demo trigger create. All right, so what this class is going to do here is, can people see that in the back, or do I need to make it a little bigger? OK. So essentially, using the schema class that Javen was mentioning about, here in line 4, we're doing a call to schema.getGlobalDescribe. And what this is going to do is going to give us all the S objects in our org. We're then going to take that map, and we're going to order the S objects by name. So we're going to iterate through the key set in our map and put them in order. And then we're going to go through them here through a for loop. And we want to create triggers for a couple of them. So right now I hard-coded them, but you can do this any way you want. Some of the objects aren't triggerable, obviously. But when we find account, contact, and opportunity, we're going to walk through some additional code. And we're going to make a schema describe S object call on that object, and take that result and do a fields.getMap call. And this is going to give us a map of all of the fields dynamically across our S object. You can see how this could potentially be used to generate maybe a dynamic test class, or really anything else you want to do with a brand new org or an existing org. From there, once we have all the fields, I'm just putting them all in a concatenated string right now that's comma delimited in a string called all fields. And then I'm putting it in a JSON string here. And what we're going to do is we're going to create some triggers dynamically. And so I am going to name it tooling, whatever object I'm looking at trigger, so like tooling account trigger. We're going to put it on whatever object we're interested in. And then we're going to put the body of the trigger in here. You will have trigger, tooling, whatever trigger on our object before insert. And then in a comment, I'm just putting our string of concatenated fields I created dynamically. I'm then going to make a call out to the tooling API here using just an HTTP call. And we're posting to Salesforce, tooling S-objects, Apex trigger. And I'm going to generate some debugging information here. So I'm just going to make a create triggers call. And I'm going to see it's going to generate some debug information here. And I see I have 3 successes over here. So now I can jump back into Salesforce. And if I navigate down here to our triggers, I'll be able to see here in a second, I just created 3 brand new triggers, each on a different object, and each with dynamic information based on that object's fields. So this is a very basic use case that doesn't really help us at all with anything substantial, but you could see how potentially I could use this to create certain behaviors, create certain conditions, implement some of the strategies Javen was telling us about to do different things on different objects, all dynamically. So that's one thing we can do with the tooling API, is create code using code. Some of the other things we can do are right here. And we can make some calls I'm going to show you here in a second in Workbench to the tooling API and generate a list of all the different objects we can operate on. I'm going to make a call to Apex manifest. It's going to give us a list of all the classes in our org, including inner classes. And then I'm going to drill down into one of the classes and construct a symbol table for you and show you what that looks like. All right, so let's go back into the developer console real quick here. And before I do that, I'm just going to bring up a different org really quick. Okay. And we'll log in. And now I'm going to go to our REST Explorer, and we're going to look up tooling S objects. We'll just do a GET request here in our REST Explorer. And I'll see that I have all these different items here that I can look at in my org. So maybe I've just changed jobs and I have a new org for the first time, or I'm a consultant and I'm working with new orgs all the time and I don't know what's in my org necessarily. I can use the tooling API to make a call on any of these different things here. You see this Apex information, there's some permission information, some workflow information, etc. And I can basically build tools, either as an ISV or on my own, to really get a good sense of what's in the org. I can take it one step further, do a call to the Apex manifest. And this is going to give me a list of all the classes in my org. If any of you have done any of the Trailhead modules, some of these classes may look a little familiar to you. But in addition to the actual classes, you'll notice that this is also giving me a list of inner classes. And so that's kind of cool that I can potentially do that. But what is that information really going to give me? I can go down in here, for example, to a Trailhead leaderboard controller. And I'm just going to copy that ID really quick. And I'm going to make another call. And this time, I'm going to take a really deep dive at my class. And so I've made a call to this class here. You see I have the name. I accidentally gave my org a poor namespace prefix. And I have the entire body of my class here. And so I could parse that if I want, but it'd be much easier just to look into the symbol table here. And this symbol table is going to give me a list of the constructors in my org, some information about them, some inner classes in my org. And it's also going to give me some other things, like methods in my org. I can see a list of all the different methods. And I can drill down into the methods as well. I could see what parameters it's taking, what modifiers it has on it, and ultimately get all that information in one spot. So at the end of the day, what can I do with all that information, though? So I have some classes in here that I'm just going to walk through super fast. Basically, a one-line interface that's just calling a method, a base class that, again, just calling some basic Boolean methods, and then a little more interesting class that's not doing too much, but it's extending the base class, implementing the interface, has a bunch of properties in it and stuff like that. But there's a tool out there called the Documenter that you can download on GitHub. And if it wants to work, what it's going to do essentially is give you a visual representation of all of the code in those classes there. So you see this is loaded up here now. And I can take a look at my class, and utilizing the tooling API and the symbol table, I now have information about modifiers on my methods, references of all my variables. I can see some variables that aren't referenced at all. And I can potentially even take that one step further and construct some tools to tell me where do I have dead code, where do I have code that's not being used very often, where do I have duplicate variables, where do I have duplicate methods, so on and so forth. All right, we'll jump back to our PowerPoint here. All right, so I showed you the symbol table visualizer. All the code's on GitHub. There will be a link in here that you can download that and play with it and extend it if you like as well. Some other tools you can build with it. Andy Fawcett, some of you may know who he is, CTO of Financial Force, built a really cool tool that allows you to generate UML diagrams from Apex. Very useful in new orgs, similar to the schema table, but a little bit nicer to look at. Automated testing tools, like I mentioned, if you can dynamically generate objects and fields, you can potentially create a dynamic test class. Like I mentioned also, tools to identify unused code. Customize your managed packages based on an org's configuration, so you can check to see, does an org have person accounts enabled? Maybe you want to execute some extra code or create an extra trigger. Does an org that you're installing your package in have multi-currency enabled? Maybe you want to do some extra stuff there. And ultimately use your imagination to take the tooling API as far as you want it to go. All right, so if you do want to learn more about this stuff, there's a lot of information in here and a ton you can do with it. Some things I would suggest: follow Andy Fawcett at Andy in the Cloud. He has an entire section on his blog that talks about the tooling API. Andy and James Lothry have also created a tooling API wrapper class in Apex that's on GitHub. Pat Patterson, former developer evangelist at Salesforce, created a tooling API wrapper in Java. If you'd rather use Java, you could also build one in C#. And the Documenter class or Visual Force page I showed you is also on GitHub, created by Tom Petros, utilizing symbol tables. And that link is there as well. The presentation will be in the chatter group on the session at the end here. All right, so next steps from here, be thinking about the right type of code for the app that you're building. Utilize design patterns to make sure your code is efficient. Write dynamic code to make sure it can be used across a variety of different use cases. Utilize the tooling API to gather granular details to build any app. And ultimately, get out there and start building. Thank you very much for coming, and enjoy the rest of your Dreamforce.